So we're kind of shifting gears a little bit. This will be our very last skill test for this whole semester. It'll be skill 11. And this isn't the skill, but it's building up the skill. The skill will involve graphing two linear inequalities and doing some shading. So what we've been doing is finding the solution, the single solution to where two lines cross. Now we're going to find the infinite number of solutions of the shaded region that two lines have in common. So that's the shift that we're taking here. So today's lesson is not too bad. It starts pretty easy. And a lot of students actually like this lesson. It's not too bad. If you're good at graphing lines, this will go well. So a linear inequality has an inequality instead of an equal sign. You know what an inequality looks like?
Yeah, inequality in number. It's a greater number. You see, the alligator wants to eat a bigger number. That's how you remember it.
So that's what an inequality is. It's the alligator.
Alabama.
So it has an inequality instead of an equal sign.
I heard your music.
Did you get this written down? So in linear inequality, you know what that is. So when I ask you to solve one, has an inequality instead of an equal sign. A solution is a little different, guys. A solution is an ordered pair that makes the inequality true. It's a point in the shaded region. It's not the single point where they cross. As a matter of fact, the point where the two lines cross may or may not be a solution to the inequality. It depends. I'll show you what I mean in this next section.
Thank you so much, Mr. Ron. Mr. Ron, thank you.
So,
what is true spelled T-R-O-O?
You literally just made me think of that, so I wrote it down.
So here's an example of a linear inequality right here. This says y is greater than 2x minus 4. Here's one right here. It says y is less than or equal to negative 3/4 x plus 4. We're not going to graph those yet. I just wanted you to have samples of what linear inequalities look like. There are 4 different rules that you'll need to remember here.
Yeah.
4 different rules. This greater than symbol here that you see highlighted here means a dashed line, and we are going to shade larger y values. In other words, you're going to shade above the line. And we'll have to talk about what we mean by above the line, but it's not difficult. If the line is going, I'll draw this one right here. There's negative 4. I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. We're going to draw a dashed line here. I guess I will graph these. And when we say above, we mean, if it's a positive sloping line, we mean up and to the left. And I'm going to do a negative sloping line down here, and I'll show you. But if it's a positive sloping line, we mean up and to the left. If it were coming down, we would mean up and to the right. But either way, above is up. It's like if you took this line and swiveled it so that it was level. Okay, if this line were swiveled so it was level, it's all that region above that flat line. So if you see this symbol, you need to know that it's dashed and it's shaded above. The next symbol is also dashed, but you would shade below, which would be this side that I didn't shade for this linear inequality. So below would be down and to the right in this case. So dashed line. The dashed line is like the open circle on the number line. Do you remember what the open circle on the number line meant?
That's when it's
There's
no line.
There's no line underneath the inequality symbol. What does that mean in terms of, do you count that one as part of the solution or not?
Oh, I know.
Yeah. It's not filled in. Yeah, that's right. And so it's the same deal with the dashed line. It's not part of the solution. You can go all the shaded region up to, but not including the dashed line. So that's what the dashed line. The dashed line is like the open circle. The next two are both solid lines, so they're solid, and we shade the larger y values, she would shade above the line. So solid, shade larger y values are above. And then the less than or equal symbol is solid, but you would shade the smaller y values or below. I can give you an example of that here. So this one, to graph it, what's nice about these is a lot of them are in slope-intercept form. If they're not, you've got to go ahead and put it in slope-intercept form first. And then graph it. This would have a y-intercept of 4 and a slope of 1, 2, 3 down, 1, 2, 3, 4 right. You draw a solid line. So above would be up over here. That would be the above part. We don't want to shade that in this case. Below would be down here. And here's the thing about it. If you're getting confused with above versus below, which some students do,
Wherever the arrow is basically pointing, that's where you should.
it is.
And
That's true. So wherever it's like it was with number lines, that's true. But here's the other thing to really make sure. Take the origin here. What's the coordinate of the origin? 0, 0. See how I'm shading towards the origin? Let's just test it. This is called a test point. I would put 0 in for y and 0 in for x. And if I've shaded the correct way, 0, 0 should be a solution to the inequality. Let's just check. This is gone. So I have 0 is less than or equal to 4. That's true. So I've shaded in. Yeah. TROO, true. So that means that I shaded the right direction. You could, you guys, unless the line goes through 0, 0, you could always use 0, 0 as a test point. Because if you're not supposed to shade towards 0, 0, it would be false. You would shade the opposite direction. I mean, when I see this, I see it as you either shade this way or that way, one or the other. It's a true or a false. So you could almost always use 0, 0 as your test point, which is nice, because it doesn't get any easier than plugging in 0, 0 for x and for y. We're going to talk a little bit more about that in another example. That is really it. We're going to do some examples now of different graphs. I want to do an example of each type, but there's not a ton here. Okay, this is kind of going back a little bit to what I just talked about. Kind of that's usually how we start, but it says, is the ordered pair a solution of this inequality? How would I check to see if 1, 2
plug it in.
is a solution? And where would I put the 2?
In X, I mean in the Y spot.
And the 1 would go in,
X spot.
and I get 2 is greater than -2, huh?
No.
Is 2 greater than -2?
No.
This is false. So is it a solution? No.
Wait. Isn't that true though?
Oh, it is true.
I'm like, wait a minute. Yeah.
It is. It is
Wait.
true. Sorry.
1 minus
2 is bigger than -2, and so this is a yes.
Yes.
Can I go to the bathroom after?
This isn't a good time. You don't want you to miss this.
I don't want to miss it either.
So we have -7 is greater than -3 minus 3. So is -7 bigger than -6?
No.
Think about the number line here. Here's -7. Here's -6, right? So -7 is not bigger than -6. This is false. So this is a no. I'm plugging in 1, -3 right here. Logan, right here. I plugged in a -3 right here. And -3 minus 3, that's where it comes from. And here I'm plugging in the -7 for y. So you're going to be asked to do that. This is actually the end of the classwork. So you might want to start with these first. I think it's like problems 11 and 13 or something like that. So checking to see if it's a solution. You try. Try this one. Just take 30 seconds to plug that in. Put the 6 in for y. It's the y right here.
Oh yeah.
Wait, did we do 3?
3 for x. So if you evaluate that correctly, is 6 less than or equal to 6?
See,
It's not less than, but it's equal to, so that works.
yes.
So this is true.
It's C.
So it is a yes. It is a solution. Okay, that's it. So there's 2 problems on your classwork like this. And they're towards the end of the classwork.
Wait, are the other ones harder?
Well, the other ones require more work. I don't know if they're harder.
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 So any questions on how to check to see if it's a solution? Plug it in. See if it's true or false. What's the graph of y greater than x minus 2? And here I explain the test points for shading. You can pick any point not on the line and see if it is a solution. If it is, you shade towards that point or over the top of that point.
No.
And if not, you shade the other way. So this one, where would I start for y is greater than x minus 2? Where should I start? Negative 2. And what's the slope?
1.
1, 1. So we just do a bunch of go up 1, over 1 here.
Basically, a diagonal line.
It is like a 45-degree angle line.
It's dotted.
And it's dotted, so be careful about drawing the graph. Why is it dotted?
Because there's no line.
Makes it look cool.
This is not a line under.
Yeah, there's not a line underneath that, so it's dotted. And then
It's not like equal to.
yes, it doesn't say greater than or equal to. It says just strictly greater than. And then would we shade above, which would be up and to the left, or below, which would be down and to the right? Above, which is up and to the left. What would be a good test point to try here, just for fun?
Oh, origin.
Origin. So we have 0. We're putting in 0 for y, and 0 for x. I get 0 is greater than negative 2. Hey, guys.
Oh, wait, we got 2.5.
0 is greater than negative 2. Is 0 greater than negative 2?
Yes.
True.
Of course it is.
So we shaded the right direction.
Oh.
How would this one change?
The line wouldn't be dotted.
The line wouldn't be dotted. We'd have a dot at 1. We'd do a up 1 over 2. Draw in a solid line here. And then which way am I going to shade?
Below.
Below.
Wait a minute.
Wait a minute. Hold on.
How do you do the next one?
I'll talk about it in just a minute. Let's let everybody get this one done. So put a dot at 1. Do the slope of up 1 over 2. And then shade down and to the right. That's the below.
This means a horizontal line for.
Y greater than 4 is like the line y equals 4. It's not just a dot. It is a horizontal line going through 4. So there's y greater than, there's y equals 4. It is dotted because there's not a line underneath this. What's one number greater than 4?
7.
So 6, 7, yep. So we would shade up here.
What? Wrong one.
So it's a dashed line at y equals 4, and then we shade above. What about x less than or equal to negative
That's a
2?
vertical line. Negative 2.
Dot at negative 2, line through it. And which way would I go, left or right?
It was right.
Because x
No,
is
left,
less
left.
than, yeah, less than or equal to.
Oh, we did this last year.
Yeah,
This is fun stuff.
it's not bad. As long as they're already solved for y. It's a little more work if you have to put it in this form, slope intercept, which you will on some of the classwork. Because I want you to practice that. So there they are. There's a horizontal line, vertical line, dashed line, solid line. Here it is, problem number 3. There's several like this on the classwork where it's not already in slope-intercept form. Now, could you use the x and y intercepts to graph this one? Yes, but you can't always. Okay, so well, you can, but sometimes you get fractional values. So this one right here, I'm going to go ahead and solve this for y, and I want to bring up something that happens when you divide by a negative. You may remember it from the beginning of the year. So I'm going to subtract 5x from each side. This should look familiar. We just did this earlier today. So negative 2y is greater than negative 5x plus 10. Okay. And then I'm going to divide by negative 2. And when I divide by negative 2, I need to flip the inequality. So it looks like this. We flip the direction when we divide by -2. So there are kind of a lot on the classwork like
How
this.
do you flip the?
How do you flip?
Oh, it's just 2 over 5.
Change the direction.
Or what?
I'm dividing each term by -2, so this would be y is less than positive 5 over 2x minus 5. And don't panic if you get fractions here. You don't have to graph it perfectly. Just do your best to estimate the y-intercept and the slope. We're not focusing, it's not like we're trying to find where the two lines cross. So you don't have to be quite as accurate in your guidance. So if you get a fraction like 5/4 or something here, just estimate about 1 1/4 and put a dot there. It's okay. It's more getting a picture of what the solution set looks like. So here, I'd put a dot at -5. I'd go up 1, 2, 3, 4, 5, and over 2. And notice I'm only doing 2 dots, and then I'm going to do a dashed line through here. And then I'm going to shade either
Down low.
up and to the left or down and to the right. Down and to the right is right.
We have to do it now. You try it.
Well, I'm going to have you do one of them. I wanted to talk about another method on one of the now you tries. So if you want to, you could use the cover-up method on this. It's a pretty good way to graph it. The problem with that is that you then don't have y less than or y greater than a certain linear equation. So then you have to use a test point to figure out which way to shade. So here's what I mean by that. What would, if I cover up the 3y, what would x equal?
2. Oh, I mean 6.
6. So I'd have a dot at 6 on the x. And if I cover up this, y would equal 2. Now here's the problem. I know it's a solid line, but because I don't have a y by itself, I don't know which way to shade. You understand what I'm saying? So we don't have a y is less than or equal to or y is greater than or equal to. We could think about what happens here. Like I subtract x over, and then I'm going to divide by 3. Is there any reason to flip the inequality? Subtract the x over, divide by a positive 3. I'm not going to flip it. I'm not going to flip the direction of this. So it's going to stay less than. You just need to be really careful with that. It's going to stay less than or equal to. But what you could do is just try a test point. What's a good test point to try? 0, 0. Let's just try 0, 0 and see what happens. If I put 0 in here and 0 in here, do I get a true statement? Because if I do, that's the direction I shade. And then this is a pretty good method for graphing. So 0 plus 0 is 0. Is that true? 0 is less than or equal to 6. So I would shade in the direction of 0, 0. So that will work. You can use the cover-up method or the x and y intercepts to graph this, and then try a test point like 0, 0. Either way will work. I kind of like the practice we get from these. What's that? Yeah, you should try this one. Try it on your own. You can do it. And then write a summary here. What do we talk about here? You might, in your summary, you might want to just summarize like something like this is solid versus dash. Okay, something like that in your summary, solid versus dash. Something like that. You want to remind yourself.
Fine.
But try it now. You try it. Then you guys need to do 1 through 15 odd on the classwork right now.
No, wait.
1 through 15 odd. Soccer players. Yeah, it's about time for you guys to go. Soccer players.
Wait, can I go? Testing outside. I'm gonna go with you. How about without you?
You can run the rest of the
I got this. I'm gonna go with you.
David, we're not.
Okay. He wants to run.
Where are you guys? Where's the soccer? Here. No, it's here. So you guys are just gonna miss every Tuesday and Thursday where it's home and playing this time class.
Lit. I mean, I get it. Every day we do it. Mr.
Like
Rouse.
volleyball. I say volleyball.
I don't think soccer actually exists.
Yeah, they did a lot.
I don't think soccer exactly actually exists.
So you should plan on doing it.
We're like riding rocks.
No, when it's when you just do that by itself. Oh, no, when it's vertical. When it's Y, it's vertical. That's not the right way. It's got to go through. Okay, so 1 through 15 odd, guys.
Yeah, I have a yellow one.